Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra I and II class. Today we are going to be talking about solving right triangles using trigonometry. But give me 1 second, please. Okay, sorry about that inconvenience for a second. Okay, guys, so I'm going to repeat what I started with yesterday. Why am I repeating this? Because trig is something that you have to just see over and over and over and over and over. It's a repetitious skill. And when we're talking about trigonometry, guys, we're talking about right triangle geometry. And when we're talking about labeling sides, depending on what angle we're coming from, okay, you got to really focus. In this particular case, the sides are labeled with respect to angle A or theta. From angle theta, the side that is across from it will always be opposite. The side that is directly next to it will always be adjacent. And I know the hypotenuse is also next to the angle, but the hypotenuse is never the adjacent, ever. So that is just simply the hypotenuse. How do you know it's the hypotenuse? Because it's directly across the 90. Okay? We said that in a unit circle, okay, trigonometry is based on triangles within a circle and the movement of that circle, or I'm sorry, of a point within that circle based on degrees. When you have this, these triangles can be calculated using the Pythagorean Theorem, which is r squared equals x squared plus y squared, where r is the radius. Okay? Does that make sense, guys? Now, I also went over the trig ratios. The main three trig ratios we can remember from the acronym, I think that's what it's called. It's a SOHCAHTOA. And SOHCAHTOA, so, opposite over hypotenuse. That's sine. Ka, cosine is adjacent over hypotenuse. Toa, tangent for t, opposite over adjacent. Then you have the reciprocal functions. The reciprocal of the sine is the cosine. So if the cosine of a certain theta, if the sine of a certain theta, let's just say for giggles, equals 1/2, that means the cosecant of that same exact theta equals 2, because it is a reciprocal. Cosine's reciprocal is secant, same difference. If the cosine of a particular theta, let's say, was, I don't know, I'm going to say 4/5, then the secant of that exact same particular theta will be 5/4. The value is reciprocated. The reciprocal of tangent is cotangent. So if the tangent of theta, for example, equals 1/3, that means the cotangent of that same exact theta will be 3/1. They are reciprocals. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Now, something that one of your fellow peers asked me yesterday, I think is very important, and I think it's going to help you guys understand what's going on here. I'm just going to show you guys roughly what the graph of a sine graph looks like. Don't worry about how I'm getting these values. You will learn this next year, I promise. Remember that I told you that trig is based on triangle geometry within a circle, right? Okay. If we go like this, that's 0 degrees or 360. That's 90 degrees. That's 180. And that's 270. That's the way a circle goes. The graph of a sine will be like this. Now, remember how I talked to you guys about values, the difference between a value and a degree? Okay, check this out. At 90 degrees, so the sine of 90 degrees has a value of 1, guys. That's my value. Why? Check it out. As this little sine starts here, okay, and I move up, think, this is 0, 1 on a unit circle. This is, I'm sorry, that's 1, 0 on a unit circle. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. So do you see, guys, as this point is moving, at 90 degrees, I get a value of 1. You with me? So if I reversed it, the sine of what theta gives me 1. At what angle measure does the sine have a value of 1? 90 degrees. That's why when you do this in your calculator is reading the graph for the answer. Is this helping putting things into perspective here? As the graph continues, now I go down, right, to 180. Look, guys, don't I go down to 180? What's the sine of 180? 0. Then I go down to 270. Don't I go down to 270 on my circle? What's the value of sine of 270? Negative 1. Then I go up to my 360. Am I not following the circle to go up again to my 360? And what is the value of 360? Of sine of 360? 0. I'm not going to get into how or what I did here, but I really want to do a good job of helping you understand what it is that we're measuring. When I'm talking about a value, do you see what I'm talking about now, guys? Does this help? Okay. If this helps, then you're really going to love this. Find the value of x here, guys. When we want to find the value of x, you have to keep in mind you're going to have to use one of the 6 trig functions. You're going to have to. So I'm dealing with angle 30 here, right? From angle 30, label the side where x is adjacent. And the 8 will be the, guys, from SOHCAHTOA, who uses adjacent and hypotenuse? Cosine. So check this out. Ready? So the cosine of 30 degrees equals adjacent over hypotenuse. Before I solve that, I want everyone to really see what I'm doing. Has to be the cosine or the secant. You could have done the secant, but the secant is more difficult because then you got to reciprocate stuff, right? So when possible, guys, use sine, cosine, or tangent. That's why SOHCAHTOA is so important. But yes, you could have done the secant of 30 equals 8 over x. Yes. But you're going to have a lot more work to do. So try to stick to SOHCAHTOA. Yes, sir. Go ahead. No, you cannot use any of the 6 functions. You can only use the functions that are applicable. Which are the only functions that deal with adjacent and hypotenuse, guys? Cosine and secant. And we don't want to use secant when at all possible because then I have to reciprocate the answers. And that's just more work. Is everyone with me here? Now, how do I solve for x, guys? Multiply by 8. So you go 8 times, literally, cosine of 30, and your answer, it's not 4, should be 6.928. X equals 6.93. Let's round to the nearest hundredths. You got 4 if you use sine. Yep. Because the sine of 30 is 1/2, but the cosine of 30 is square root of 3 over 2. Yes. What other way? Wow. Wow. You are awesome. Okay. You're amazing. I wasn't gonna get into that because again we're getting deeper, but I'm gonna show the class what you did. Since my boy paid attention to my lesson, thank you so much. He remembered. Wait a second, Morrow. If that's 30, this has to be 60. And if that's a 30, 60, 90 triangle, didn't we say that this is an x square root of 3 and 2x? So if the 90 is 80, that's half of the small side. The small side goes to 30, that's 4. The side across 60 is the small side times the square root of 3, which would have been the same exact answer. But again, we're just scratching the surface, but you are really going to have a head start for next year. Thank you. Now, let us continue though, guys. Fantastic, by the way. Now here you're out of luck, Chuck. Here you have to use the trig functions. In this particular case, it's solve x, y, z. When I say solve, or when a test says solve, or when a quiz says solve, that means that they want every single missing value. So what I like to do is organize myself. I want to find angle y. I got to find what x equals. And I got to find what y equals. Angle y is Mickey Mouse. How many total degrees in a triangle, y'all? What's 180 minus 90 minus 35? 55 degrees. So you already found y. Now, from here, who do you want to work with? 35 or 55? You always have to make these choices. 35. I say that's a great idea. Let me explain why you always work with what was given. Could I have made a mistake and accidentally put 65? If I made a mistake here, guess what? Now this is wrong, and that's wrong. Does that make sense, guys? So always do your best to try, to the best of your ability, to work with what was given, okay? And let's not confuse ourselves, that is 55. Okay, so now, from 35, let's label the sides. The x would be the excellent, the y would be the excellent, and the 10 would be the, okay. Who do you want to solve for first? X or y? I don't care. These are choices you have to make, guys. Okay? Who uses opposite and hypotenuse? Sine, right off the bat. Good job. So the sine of 35 degrees equals opposite over hypotenuse. Now this, unfortunately, guys, there is no other choice. You have to either use a table, which is the way I used to do it back when the dinosaurs roamed, or with a calculator. So you go sine of 35 times 10. What you get? Let's round to the nearest hundreds. Excellent, 5.74. Beautiful. Now, x is 5.74. We're done with that guy. Now I want to show you something, because there's a lot of beautiful connections here. At this point, guys, you could go ahead and use the Pythagorean Theorem and go 10 squared equals 5.74 squared plus y squared. But I wouldn't do that. Me. Because those numbers are ugly and it's nasty. Me, I'm going to use trig again. I want to solve for my y though, y'all. Who uses adjacent and hypotenuse, guys? Cosine, thank you. So this time the cosine of 35 equals adjacent over hypotenuse. Does that make sense? And then the cosine of 35 times 10 equals 8.19, rounded to the nearest hundredths. And my friends, seriously, this isn't like super duper crazy heavy trig, but this is pretty awesome trig that you guys are just understanding. I'm very proud of you. Sir, my brother. Yes? Okay, the question was, if I did it to the Pythagorean Theorem, yeah, you may be off by a decimal or so. I'm not going to, cry about it. But I think that for time, for speed, it would behoove you to use the trig. But the answer to your question, no, I'm not going to penalize you for using another valid way. Thank you, my brother. Sir. Yes, my man. Okay, thank you so much. The question was, when you were finding the adjacent, why did you use the hypotenuse and not the opposite? First of all, I'm not trying to be sarcastic at all. Cosine uses adjacent over hypotenuse, right? So I'd have to use it if I was going to use the cosine. Now, I could have used tangent, and then it would have been opposite over adjacent. However, could I have made a mistake here because I'm a human? So you rarely want to use values that you just found. You always want to use values that were given because you know that those are for sure legitimate answers. Thank you so much. May I continue, gentlemen? Okay, let's do this. Okay. But yeah, I know it's not a super awesome drawing, but I do the best I can, guys. I at least I make my own notes, right? Okay. In order to construct a bridge across a river, by the way, as Mickey Mouse as this looks, this is legit, man. This is how people find distances across rivers that you cannot find distance otherwise. In order to construct a bridge across a river, the width of the river at the location must be determined. Suppose a stake is planted on one side of the river, okay, right there, directly across from a second stake on the opposite side, okay? At a distance of 50 meters to the left of the stake, an angle of 82 is measured, it's over here, between the two stakes. Find the width of the river. Let's clean this up a little bit. Guys, this is real life. Like, this is real life, I promise you. Let's find that width. I've got 50. What is 50 when we're talking about 82 as my angle? The adjacent, fantastic. And then, am I looking for my hypotenuse or this W? And the W is the, thank you guys. My brothers from Sokotoa, who uses opposite and adjacent? Heck yeah. So you're going to go tangent of 82 equals opposite over adjacent. Would you guys kindly create that math problem on your calculator and do it? Tangent of 82 times 50. That's exactly right. W equals 355.77 meters. Remember, there's about 3.3 meters in every foot. I'm sorry. There's 3.3 feet in every meter. So if I multiply that times 3.3 roughly, we're talking 1,174 feet. That's a long, that's a wide river. That's realistic. And again, some of you I know may be thinking, wait a second, Morrow, can't you get on a boat and just go across with a tape measure? No. First of all, even if they did make tape measures that long, I want to show you guys the logic of why that wouldn't work. If you're going along on water, do you go straight? No, guys. If anyone has ever been on even a rowboat or a canoe, if I got to go from here to here, I've got to go like this. That's a heck of a lot longer of a distance than just a straight line. Does that make sense? So that's why you can't just go and on a boat or, hey, Charlie, I'll swim in with a tape measure. You can't do that. Okay, yes, sir. Shh. Guys. Okay. The question was the tape measure doesn't go down. Yes, it does. Because what happens is, okay, if I'm pulling the tape measure, when I go up like this, aren't I also extending that tape measure? Because the tape measure is getting pulled up as well. Yes, sir. When you get to the other side, you're going to have a huge gap left over, guys. The tape measure is going to read longer than the actual distance is. Okay? Trust me, guys. There are not tape measures out there with thousands of feet. I promise you, this is how they do it. Okay? Sir. Okay. What happens when the variable is on the bottom? You solve like normal. Let's say that you had, for example, the tangent of 36 equals x over, 14 over x. Solve for x like normal. Multiply x to both sides. So I got x times the tangent of 36 equals 14. Solve for x by dividing the tangent of 36 to both sides. So in this case, if that was the question, if that was the way it's set up, it'd be 14 divided by the tangent of 36, which would be 19.27. Does that make sense, sir? So you just solve like normal, my brother. Thank you. Yes, sir.
That says that he's an electrical engineer.
Yes, sir.
Every day he uses this because he works in power quality.
Yes, sir.
When they figure out the ratios of power delivery versus price,
Right.
it's a certain angle that they need, and he uses this to figure that out.
Absolutely. One of my students just said his father's an electrical engineer, and they have to use this every day to find ways that power can go to where it needs to go. Power has to travel through angles as well. Thank you so much for sharing that with me. That means a lot to me because you guys can see that this is real life, man. It's not just for fun. So proud of you guys. Good job. Let's continue. All right. Let's practice, guys. Okay? I want you to solve each right triangle. All I have here is that, oh, and by the way, let's not stress you out. This little symbol, that's a lowercase alpha. This little symbol is an uppercase beta. Remember, this little symbol is theta. They're Greek letters. It's very commonly used Greek letters to represent angles of a triangle within trig problems. So don't let that stress you out, guys. So, number one. Okay, man. Let's find alpha. What is it? That one should be a no-brainer. No. Not 44. 34. Very good. Okay, now, remember, guys, we have to choose. What angle are we going to work with? 56. Who do you want to solve for first? I really don't care, my brothers. A. Okay. From 56, can we label A, please? Very good. Can we label B, please? Very good. And you all know that 15 is the... Thank you, gentlemen. Okay. So, who uses opposite if you want to find A and hypotenuse? Sine. So the sine of 56 equals opposite over hypotenuse. So the sine of 56 times 15 would equal 12.44. Always round to the nearest hundreds, please, unless otherwise told. 12.44 feet. You guys with me here, guys? You sure? Because I'm going to erase this in a second. Okay. Now let's find B in blue. Who uses adjacent and hypotenuse? Cosine. Good job. So the cosine of 56 equals adjacent over hypotenuse. So let's go ahead and do that math, please. Cosine of 56 times 15 equals 8.39. Excellent. I think you had reversed it, my man, because you gave me that answer for the first one. Be careful what you guys what button you strike on the calculator. It can mess you up. Does that make sense, gentlemen? All right. You know what? I'm bored of this type. I'm gonna switch it up. Hold on. Yeah, you guys are too good for this. Hold on. Hold on. Just settle down. No big deal. Let's just go ahead and switch that up, okay? And in fact, you know what? I don't like any of this. I don't like that it's all cramped up like this. So let me just do that. Go here. Hold on. Okay, now I can do it here. Okay, my brothers. I've got to find angle theta. And then I got to find A and I got to find B. What's angle theta right quick? 53, thank you very much. Okay, now, what angle do we want to use? 37. Can you please label A for me? Can you please label the side that is marked 33 for me? Can you please label the B for me? Trust me, guys, eventually, you won't have to label them. You'll just know. But for now, please, do 100 like this so you really understand it. So, who do you want to solve for now? Again, all of these questions are valid every single time. Who do you want to solve for? A. Okay. Who uses adjacent over opposite? Because those are the only two sides that I have. Tangent. Thank you. So the tangent of 37 equals opposite over adjacent. So let's do this. We got to solve for A first. So I'm going to multiply A to both sides. So I got A times the tangent of 37, equals 33. To solve for A, let's divide by the tangent of 37 to both sides. A will now equal 33 divided by the tangent of 37, which equals 43.79. That's rounded to the hundredths. Excellent. 43.79 inches. Does that make sense, gentlemen? Okay. You sure? Because I got to erase this too. Yeah? Okay. Thank you, guys. Okay. Now, I want to find B. Who uses opposite over hypotenuse? Sine. So the sine of 37 now equals opposite over hypotenuse B. Solve for B, guys. As you can tell, it's always going to be the same pattern. So in the end, B is going to equal 33 over the sine of 37. Do you guys understand the math, what I did there? Okay. Because those canceled and I had divided by the sine of 37. Go ahead. You could have done the Pythagorean Theorem. Yes, I'm not going to take points away. Since I'm teaching the trig, I just want to really ingrain that in your head. Thank you so much for caring. So 33 divided by the sine of, that will equal 54.83 inches. Thank you, gentlemen. Excellent. Excellent. Sir, what would I rather use? Trig. Unless they were really simple numbers. It's just that, think about it, guys. Just look. On your calculator, you'd have to do, let's say that I used A in the hypotenuse. So I go 33 squared, 33 squared plus 43.79 squared equals B squared. Then I got to square both. Then I got to add them. Then I got to put in the square root. So it's just a matter of time for me. Math is the math. It's going to be the same. Within, plus or minus a tenth of a decimal. But for me, it's quicker to go that route. Me. Sir. Greek letters are always used for the angles. Yes, sir. All right, boys. Let's switch back here. I think I'll have room for this one now. Okay. How about this bad boy? Now we're talking. We are not given any angles. Oh yeah. But what do we use, guys, to find the angle? The inverse trig functions. Very good. So check it out, guys. What angle do you want to solve first? There's a lot of choices. Theta? Okay, great, because there's no theta here. Alpha. Okay, you want to solve for this guy. My friends, from this alpha, who is 19.67? From this alpha, who is 37.21? Okay, stop right there because you're not going to use that. You don't need to label that right now, but that's the opposite. Okay, who uses adjacent over hypotenuse? So if I want to find the theta, I go inverse cosine of adjacent over hypotenuse. See why we learn how to find the angle? You have the value of cosine right there. What theta gives me that value? Where on the graph is this point that gives me the value of 19.67 divided by 37.21? So you go inverse cosine of 19.67 divided by 37.21. Thank you. That equals 58.09 degrees. Now, do I have to do the inverse again to find B? No. Go 180 minus 90 minus 58.09. And that equals 31.91. Just to prove it, let's just prove it, okay? From B, we'll do it in blue. What is the 19.67? Opposite. From B, what is the 37.21? Still the hypotenuse. So I would go inverse sine of opposite over hypotenuse. Please do me a favor and do that math. Inverse sine of 19.67 divided by 37.21. And that equals 31.91, guys. So either way is fine. And then last but not least, now that we have my angles, now here you are stuck, aren't you? You're going to have to use one of the values you found. Remember I told you that whenever possible, use what they gave you. But in this case, guys, you had to solve. So first of all, who do you want to use to solve A? You want to use alpha? Okay, did you have a question, bro? Or yes. Okay, you were thinking really, really well. My boy just said, Mr. Morrow, that's fine, but can't you just use the Pythagorean Theorem? Yes, you can. But just because I want to practice the trig, let's do it trig way. But thank you, your logic is awesome. Great job. So, to find A, guys, you guys said you wanted to work with alpha, which is 58.09. So, who used it? Well, from alpha, what is A? From alpha, what's 19.67? And from alpha, what's 37.21? Okay, now you have, again, more choices. You can use either opposite or adjacent or opposite over hypotenuse. Again, what would you like to use? All right, we got a little bit of both, so I'm just going to do tangent since we haven't done it. Opposite over adjacent. So tangent of 58.09 equals opposite over adjacent. Go ahead and solve for A. Tangent of 58.09 times 19.67. Tangent of 58.09 times 19.67. That should equal 31.59, and of course that's centimeters. Excellent. You guys getting how to solve triangles now? Okay, now, The reason why I've been so meticulous with this is now, guys, with word problems, you're going to have to draw your own triangles. But please don't stress. May I erase this? Guys, yeah? Bless you, son. Okay. Yes. Okay, you're going to have to watch the video at this point. Okay, thank you. If the flagpole that a golfer aims at on a green measures 5 feet from the ground to the top of the flag, and a golfer measures a 3-degree angle from the top to the bottom of the pole, how far in horizontal distance is the golfer from the flag? This is actually the best kind of word problems because you can draw it out. First thing, a flagpole. Okay, so I have a little flagpole here, and a golfer's aiming at it. So that means the golfer's right here. Do not make fun of my awesome drawings. Okay? And it says that the flagpole that a golfer aims at on a green measures 5 feet from the ground to the top of the flag. So that's 5 feet. Here's the ground. Whoa. Just cut his legs off. Here's the ground. Okay? You with me? Okay. And then it says, and the golfer measures a 3-degree angle from the top to the bottom of the pole. So I'm making it way larger than 3, but here's 3 degrees from the top to the bottom of the pole. Right? Yes, guys? So it says here, the golfer measures a 3-degree angle from the top to the bottom of the pole. How far in horizontal distance, so how far is this? This is simple. If that's 3, guys, what's this? 87, right? Okay. From the measure of angle 3, what is the 5 known as? Adjacent. What is the x known as? My brothers, from angle 3, who can I use that has opposite over adjacent? So the tangent of 3 degrees equals opposite over adjacent. Can you please tell me what the tangent of 3 times 5 is? 0.262. That doesn't make sense. That's really close. That's like right on it. Let me see something. The ground to the top of the 5 feet from the ground to the top of the flag, and the golfer measures a 3 from the. I messed up because I don't know how to read very well. I apologize. Everything else is fine. Yeah, I'm a math major, but that's still I should know how to read. This is still 5. Okay. Here's the angle, though. It makes more sense. Because think about it. If the dude is here on the ground, right? He can measure this angle by looking up, right? Okay, it's a 3-degree angle. So that's still going to be 87 here. I want this. I'm still going to use tangent, right? But the right way this time. Tangent of 3 equals opposite over adjacent. Multiply x to both sides, divide by tangent of 3. X equals 5 over the tangent of 3. Now let's see if that makes sense. That makes sense. 95.41 feet. I really apologize about that, guys. I don't think I wrote that question very clearly, apparently. And I apologize. There's no excuse. But does that make sense? You promise? Yes? Okay. Let's practice. Dale. Enjoy it. Homework's valid. I'll walk around to help you out. Thank you. Hope you learned a lot.